So most of the time, we've been using efforts between 3 and 5 seconds. Recovery, most of the time, passive in between those sprints, 15 to 20 seconds. We generally perform 4 to 6 sprints in a row, and then longer rest, like 2, 3, 4 minutes in between. Another type of format which is a bit different, a bit less used in the literature, but that I've seen in different teams as well in practice, is just to alternate efforts of 6 seconds with rest of 6 seconds over a minute. So it becomes a bit more an aerobic type of repeated sprints, which hasn't been much studied in the literature, but I found it interesting, and that's why I'm just mentioning that. Most of the time, we've been using repeated sprints to target high levels of mechanical work, which is never really a problem in terms of injury risk and so on. So I think it's a good option to build up the mechanical work and the ability to repeat mechanical types of actions, so repeat accelerations, rather than repeating high speed, which obviously involves or increase a little bit the risk with the fatigue and so on. So since we tend to be a bit, let's say we're trying to lower the risk during training, if repeated sprint has to be performed, or repeated actions, I would get rather for repeated acceleration than repeated full speed, even though it can be implemented, but probably not over the 12 or 15 repetitions. Again, depends on the context, depends on the timing in the microcycle, timing in the season, player profile, and so on. But again, it's not about, we've been talking about repeated sprint, but what I mean is that we can have the same idea that we have with the short intervals, with adding some turns even during the sprints. So it becomes not repeated high speed, but it can become repeated acceleration and so on. That's the main idea. So using the COD, the chain of directions, to, as always, modulate high speed versus mechanical work. Those specific movement patterns can obviously be as well position specifics in terms of just pressing, recovering a ball, passing, and so on, exactly as we discussed for the short intervals. Most of the time, because those repeated sprints are very, very specific in terms of physiological demands. Remember, as we discussed in Lens, repeated sprints targets, there are type 4 targets, so they target the oxidative, anaerobic, and neuromuscular demand at high levels. So considered as very specific, they are probably good to be used at the late stage of the preseason to prepare players to the game demands, but they can also be used for substitutes to kind of compensate for the lack of stimulus that they're missing of not playing, and maybe as well at the end of the return to play process with those players. But again, as you see, it's always been an end or a substitution of game demands. So we have to be mindful of obviously not using repeated sprints when the season starts, for example. That wouldn't be really appropriate. All right, so moving now into the largest part and presentation of our weapons or hit formats, namely the small-sided games. So they are way the most utilized, as I was saying. Probably 80% of the time we condition players, we use small-sided games, but it's mainly a team approach, a team format, a team weapon, while the other run-based, especially the short intervals, will be more an individual player tool for rehab, individual top-ups, subs, and so on. So when we think team, we think using small-sided games. The good interest is that when they are well designed, they could lead players to reach very high heart rates, very high levels of lactates, and still a manageable level of neuromuscular load that can be manipulated with obviously a lot of change in rules, such as the length of the pitch, the number of players, and so on, as we're going to discuss after. But overall, and to be honest, I was a bit skeptical at the start when I started to work more in football about 10 years ago. I never really believed that they would be that efficient in terms of developing physical qualities, and I always kind of thought that we need to go through at some stage through more generic type of running, And if we recall a bit my analogy to the two-spaced theory I was discussing in the part 1, where sometimes we need to press on very, very clear and defined targets to really get improvements into for elite players. But I have to admit that because of the quality of those games, especially when they become very competitive, players manage to get improvement in most of the physical qualities, and even in terms of speed and strength, that still participate into at least maintaining those qualities. So it's pretty interesting. And obviously, on the top of all this physiological adaptation, that's the only way you can still work on the technical aspects, a bit of tactical aspects, but at least decision making under pressure, maintaining skill quality with fatigue and so on. And so obviously it's pretty interesting format because it kind of touches all the aspects of football, not only the physical aspect, but also the specificity of the game at the same time. So what we're going to discuss a bit further now is how we can manipulate those drills to really target a bit as we do with the intervals, the short intervals, to target differently the different physiological responses. So on this figure, it's kind of a summary of all the findings from the literature that I tried to put in one slide, where we discuss and we see how changes in player numbers affects the response based on our 3 categories as always. So as you can see, if you really want to hit and to spend some time in the red zone, like close to VO2 max, it's probably only the 4x4 formats that will allow the aerobic intensity to be so high. And then as long as we we increase the number of players and the pitch size as well, the level of aerobic demands decreases. If we look at the level of anaerobic demands, our second target, it follows more or less the same. The 4x4 are pretty high in terms of anaerobic demands, and when we move to 5, 6, 7, 8 versus 8, those anaerobic demands decreases. The third level, in terms of neuromuscular load, as you're gonna guess now, has been divided into the high-speed component and the mechanical work component. And for the mechanical component, in the bottom of the graph, we have the same pattern as VO2 and lactate. So 4x4, pretty high demands, and as we increase the number of players, there will be less interaction with the ball, because just the ball will have to be shared with more players. So less interaction, less pressure, so the amount of mechanical work will decrease as well as we increase the number of players. However, the amount of high-speed running, in that case, will be inversely related to not only the players, but the space. So the greater the pitch, the greater the loading in terms of high-speed running and likely hamstrings loading. So just that, it's already pretty interesting. If you want to target different level of neuromuscular load, that just show you simply that modulating the number of players and the pitch size will help easily to make the decisions based, obviously the decision will be based on your context and the programming and the weekly macrocycle and so on. But once you have defined your targets, once you have defined the type of solicitation you have, you can now just modulate the response while changing number of players and pitch size, for example. To go a bit further than that, so far, most of the time, the programming of small-sided games has been based on the graphic I was just presenting. So we know in advance more or less what are the responses to those different types of small-sided games, and then we can just select them to select the most appropriate that fits our periodization or what we want to implement. To go a bit further and to be again a little bit more following the tactical periodization paradigm that we also discussed in length in part 1, we can now have another approach, and instead of looking at the absolute demands of those drills, we can have a look to those demands, but in comparison to game demands, as we were discussing before with the absolute volume of high-speed running with the short intervals that was related to the game demands as well. In that case, we can go a bit further and try to think for this particular 4x4, which is the intensity in terms of high-speed running, in terms of mechanical work that we touch during this 4x4 compared with the intensity that is reached during the game. So not only are we talking about volume, but what probably matters the most, and if you remember again the part one, we're discussing a lot how the intensity of exercise is important when it comes to programming HEAT, and we discussed the 30-15 and so on. In that case, to assess the intensity of small-sided games, it becomes a bit more critical. Because if you just look at the intensity overall a block of 4 minutes, or even during a game, it's very difficult to assess the intensity of a game because we have blocks of 45 minutes. So to go a bit further, what we can try to do, because we cannot assess intensity throughout a big block, we can look at very thin, very narrow windows of activity. And we can, for example, look at 1 minute periods, 2 minute periods, 3 minutes, very small periods, and look at what is the intensity over this period. And with a little bit of modeling, with a little bit of data analysis, which is not done in 2 minutes, we can have an idea of what is the highest intensity reached in terms of meters per minute, in terms of high speed per minute, in terms of mechanical work per minute. We have an idea of what's the highest intensity that is maintained over 1 minute during a game. What is the highest intensity that is maintained over 3 minutes. And when we do that, we can have this kind of curves using a power law relationship, where you can see for total distance, high-speed running, mechanical work, on the left for game positions, types of small-sided games, and on the right for possession games, type of small-sided games. So game simulations, on the left will be with goalkeepers, and the possession will be without goalkeepers. What you have on those graphs, you have the gray curve represents the game demands in terms of, as I said, total distance, high speed, mechanical work. You have the game demands on gray, and on the top of that, you have the different small-sided games, or a selection of small-sided games like 4x4, 6x6, 8x8, 10x10, and how those small-sided games compare to match demands, but in terms of intensity. And as you can see, if you look at the left side, for example, if we start with the red arrows that represent only the few options that we have when we use small-sided games to overload the mechanical work intensity of a game. And as you can see, it's only using 4x4 over 1 to 4-5 minutes that players can reach a higher mechanical work intensity than during games. That's the only small-sided games that allows to overload this mechanical work intensity. Whatever the other small-sided game formats or over longer duration, there's no clear overload. But at least that tells us that when we want to overload these components, so likely on a strength type of day, if we think about the tactical prioritization paradigms, they are probably the formats to be used during those days. If we think about maintaining high-speed running or overloading high-speed running with those games, as you can see in the middle graph, there's just no way. There is not a single small-sided game format that allows to overload the intensity of high-speed running that is reached during a game, which is simply related to the spaces. Small-sided games means less spaces to run, then most of the time it's just impossible to reach those high speed. The only small-sided game option will be a 10 versus 10 that will allow to more or less reach or match game demands. But we cannot overload high-speed running with small-sided games, which is pretty an important information, and that will explain why we also need to use the run-based generic type of short intervals most of the time to make sure we can also overload this component. So with small-sided games, we can overload the intensity of mechanical work, but we cannot overload the intensity of high-speed running. And that's why we need those external types of play. Which is also interesting if you look now on the right side of the figure, if you look now at the possession types of game. Those possession type of games tend, irrespective of the number of players, they tend to underload players in relation to game demands. They obviously underload the high-speed running component, but they also underload the mechanical work intensity. And that's pretty interesting as well when we consider this tactical periodization paradigm. When we're looking at some stage of the week, probably the second day when players are back from the rest day or they're still in the recovery phase, or the endurance day, when we just want to have some easy neuromuscularly low neuromuscular demands of those sessions, that's just matching a practice. That's what everyone does, but that just matches practice. That simple possession games are actually a way to unload the neuromuscular load compared with game demand. So that will performing possession games likely allows players to relatively recover this specific physical capacity. So again, very useful information when it comes to periodize and use those small-sided games. So what would be an example of a strength day, or what would we use in terms of those small-sided games? So the typical 4x4, 3 to 4 minutes bout. But it's still important to note that even though they are likely interesting to over-stress or to touch higher levels of intensity in terms of neuromuscular demands, we know as well that those games are pretty demanding in terms of lactate production and also VO2 max, which shows again that when we use those typical drills, we cannot isolate one of those physiological targets. So remember that small-sided games those ones are type 4 types of intervals. On one side, we have an overloading of the neuromuscular system, which is good, but we can also get some benefits in terms of metabolic conditioning and especially VO2 max, which is interesting as well, but needs to be considered in the puzzle. They are type 4, so they're touching a bit all the targets. They're touching all the targets at high intensity, but what is interesting is that the actual fatigue generated by these typical strength session or by this 4x4 are not exaggerated. As you can see on this graph, we've been using CMG responses before and after those games to have an idea of the level of neuromuscular fatigue that will arise after 4x4. As you can see, immediately after the 4x4, in our case, there were only 4 players among 21 that actually showed a decreased CMG performance. A lot of them even showed an improved CMG performance, which is often the case, and is kind of a potation effect, warming up effect. But anyway, that shows that very, very limited acute fatigue. And looking at CMG again the day after to see if there was any carryover fatigue effect or any residual fatigue the day after, and again, not a single player showing a decreased CMG performance the day after. So again, using small-sided games, highly demanding 4x4 formats a given day doesn't seem to impair neuromuscular or doesn't create a large amount of fatigue immediately or even the day after. So in our context, so every day we're going to push and train through another quality. That means that it works perfectly. In our case, the neuromuscular system was likely already recovered the day after. Interestingly as well, and that's a slide that is also presented in the tracking monitoring lecture as well. If you want to understand a little bit more what happens on the neuromuscular system level after those type of specific strength session, we've been using some specific measure with the GPS, doing some tests before and after those sessions. So if you look on the graph, you have some typical neuromuscular testing data, like quantum movement jump, as we discussed. In average, no changes after the session. Groin squeeze, sometimes a small decrease can be observed, but nothing major. And then with the GPS, we can assess the level of neuromuscular stiffness or leg stiffness, which is even improved after the session, as if we have a better better ability to restore energy. So actually nothing showing fatigue, what I mean, because neuromuscular fatigue will be represented by a decrease in stiffness, so no change or even increment in fitness. If you look at the peak impact forces, which is also often increased with fatigue, no changes. And interestingly, and probably the most interestingly, what we observed after those type of strengths-oriented session, including our 4x4 types of small-sided games, we even observed an improvement in locomotor efficiency that we assess through specific indexes using the accelerometer on the GPS. I won't go further here, and I refer you to the other lecture to understand more about this index. But the idea is that those strength-oriented sessions are actually able to acutely improve the locomotor efficiency of the player. But overall, they are not creating an important level of fatigue. So with those sessions, we likely overload game demands. So we're at least preparing players to more than the worst case scenario. We're preparing them to do more than the game, which is likely to be already a kind of stimulus for improvement. But importantly, we're not creating excessive fatigue, and players will likely to be recovered the day after to prepare and to work on likely other tactical contents, but also to work on another quality. Like, for example, working on what we call our endurance or aerobic kind of days, where in this case, we're going to try, as we discussed before, try to use more possession-based games in a format of 6 versus 6, 8, 10, 10, which are going to be more like type 1 or maybe type 2 targets, but definitely less lactate production, and as we saw with possession games, lower neuromuscular demands than during games. So pretty interesting to decrease and to make sure neuromuscular systems keeps recovering. So again, trying to fit and to use the format that is the most appropriated for a given day. But we arrive to this conclusion by thinking first about the types, the physiological targets, and then we try to find out what is the best format in terms of heat to fit to those targets. So those prolonged 6 versus 6, 8 versus 8 types of intervals over minimum 8 minutes or even 15 minutes for 8 versus 8 are likely to help players to work on their endurance, so be able to work for longer time, but without having increased neuromuscular demand and likely less fatigue, which is likely to help them to recover and get ready for the next session. What always comes the day after is a speed session. And we obviously want the players to be as fresh as possible to prepare this speed session. That's why having low neuromuscular demand is so important. If we go back to the same slide I was showing before, looking at the response of the neuromuscular fatigue measures before and after those sessions, as we saw before, after an endurance type of session, we have even an increase in CMG, so that means no fatigue at all. Small decrease in groin, which was seen after all sessions. A bit of an increase in stiffness, that means no major fatigue as well. We had a little bit of a decrease in locomotor efficiency after our endurance type of session. But that doesn't mean fatigue, that does mean a kind of reduced ability to push forward, which is probably linked more to the high volumes of this session. But again, given the small amount of changes, it's unlikely to be a problem for those the speed sessions coming the day after.